When we work with APIs, we often run into a few specific needs that are captured under advanced settings. Let's explore each of them and figure out what they do. First, let's talk about making an API call private. By making an API call private, you route the request through Firebase Cloud Functions instead of directly from the client. But why? Storing secrets, tokens, and information on the client app, like a mobile or web application, is not secure and can be revealed, which means anyone can find it and get access to your server. This setup keeps sensitive information like API keys and tokens secure, as they aren't exposed to the client side. Once this option is enabled and saved, then you need to deploy the APIs. Keep in mind that if you make the API call private, Firebase should be connected to your project. One last thing. You can force a user to be authenticated via the Firebase authentication to make these API call. To do that, turn on required authentication toggle. Just keep in mind that if you enable the required authentication toggle, Firebase authentication must be configured appropriately. Next is process streaming response. A stream response allows your app to handle data continuously sent from the server, such as live updates or ongoing data streams over an HTTP connection. Imagine you have a live sports score app. While streaming responses, your app can display real-time scores as the game progresses without needing to refresh or make new API requests constantly. Next is proxy setting. To understand why this setting exists, you must first understand CORS. But what is CORS? CORS, or Cross-Origin Resource Sharing, is a security feature in web browsers that prevents a website from requesting data from a different domain, in this case origin, without permission. How it happens? Well, when a website tries to access resource like APIs on another domain, the browser checks if the other domain allows this by looking at specific headers in their response. If not allowed, the request is blocked. There are several ways to fix this issue, but one common one is to set up a proxy server. A proxy server acts as an intermediary between your app and the internet. It helps bypassing restrictions, enhancing security, and manage traffic efficiently. In FlutterFlow, when you test your API calls inside our builder, run mode and test mode, we use a proxy to route your calls by default to avoid the CORS issue. However, if you want to use your proxy, you can disable these settings and provide your proxy URL. Next, let's talk about cache API results. Imagine your app frequently requests weather data that doesn't change every second. Repeated API calls could slow down your app and increase your bandwidth usage. Caching stores the result of the API calls locally for a specific period. When the same data is requested again, the app can return the stored data instead of making a new API call. This speeds up response time and reduces the load on your server. Let's talk about decode responses as UTF-8. UTF-8 is a standard encoding format that ensures text and symbols are correctly displayed across different platforms and languages. Enabling UTF-8 decoding in your app ensures that all text data received from an API is correctly interpreted, preventing issues like garbled text or unorganized symbols. If your app pulls data from a multilingual news API, decoding the response as UTF-8 ensures that all articles displays correctly with proper characters and symbols regardless of language. And lastly, let's talk about API interceptors. You are developing an API requiring an authentication token for every API request. Manually adding this token to each request can be tedious. An interceptor allows you to capture and modify API requests and responses before your app sends or receives them. It can be used for tasks such as adding authentication tokens, logging, or error handling. It acts as a middleman between your app and the API server. So when you make an API call from your app, the request first passes through the interceptor. The interceptor can then inspect the request, make changes like adding headers or modifying the URL, and even cancel the request if needed. Similarly, when the server responds to your request, the response passes through the interceptor before reaching your app. In fact, an interceptor is a class to which you can add your custom code to modify requests with the onRequest method and responses with the onRespond method. When you add interceptors and create a new one, it will open it in a custom action editor. This is similar to what you did to create a custom action. Only the interceptor class has onRequest and onResponse methods. You can add interceptors to any API call. While you can use Code Copilot in FlutterFlow or write your custom code, one tip is to use ChatGPT just by writing a proper prompt and potentially the source code from the boilerplate code. One more tip. When multiple APIs uses the same interceptors, you can create an API group and add the interceptors under the advanced group settings. However, you can still override the interceptors for any API within the group if you wish to. All right, that's it for the concepts. Let's move on to the next video and see it in action in a quick demo. All right, back to my project, and now we're gonna go and add interceptor. I'll open the API call, and you can add interceptor to both API group under the advanced setting of the group. You can find the add interceptor, or you can do that on individual or each API call under the advanced setting. So I will go ahead and add this right now to my category API group. Let's go on under the advanced group and add a new one. So I don't have any interceptor created as of now. When I create it, then I'll get this boilerplate code. It's in fact a custom action code. You can define arguments and return even value here. So let's go ahead and save this. And once I save that, then I can go back to my custom code and the interceptor is appearing under the custom action. Let's write an interceptor here. I want to have an interceptor to add a custom header on request. So let's just rename this. I'm going to go to the boilerplate code. And you see now that it says add header. All looks good. Let's copy to editor. So, and let's save. All right, now let's take a look at the interceptor method here. So we have the onRequest, which has the API call options, and also the onResponse, which gives you the API call response and also another function for retry. So what we can do right now, we can take a look at the options on onRequest. Let me just write this and press dot. And these are the options that you can modify right now for the request. You get all of these values and you can actually change and modify them. You can add like params automatically, or you can go ahead and add a headers. So what we can do right now, I'm going to add a headers in this case. And imagine our backend developers told us we need to pass a custom header on all of our API calls for a category. So I'm just going to go and define this as X device, and let's pass just mobile. So this is a very simple interceptor, in fact, but we can definitely do more than this if it's required. For example, you can also go ahead and add the authorization header, which you need to add to all of your calls. You don't need to do that for each call one by one. You can create an interceptor, and that will take the current auth token from the user. Here is an example, and add it to all of the calls. Beautiful. So let me go ahead and save this action. And now go back to API call. So now this time under the category, if I go to the setting, I have the add header interceptor added. I can go ahead and add even more interceptor in this case. I just don't need to add one. Let's go ahead and create a quick one again. This time, I'm going to go and add limit as a query param to all of my requests. Let's go ahead and do that. So I'm going to have an options here, and then let's get the params. I'll just add limit, and in this case, always going to make sure that we pass the limit as 10. All right, sounds good. Go ahead and save. All right, now we can go back to our API call. Now you can see that we have two interceptor, and you can even go ahead and reorder them if it's necessary. All right, that's it. So that's how we are creating interceptors. So far, we've worked with REST APIs. REST APIs have a few characteristics. Let's quickly review them. The client sends a request and server responds with the data. That's a request response model. So each request response pair is independent, and the server closes the connection after sending the response. It is usually suitable for application where data stays mostly the same and real-time updates aren't critical. The typical response of REST APIs is JSON format, and we've learned how to parse and work with it so far. There's another type of API now too, streaming APIs. Streaming APIs provide a continuous data flow over a long-lived HTTP connections, enabling real-time updates for your application. Unlike REST APIs, which delivers data in response to a specific request, streaming APIs are designed to maintain an open connection between the client and the server, continuously sending data as it becomes available. This is particularly useful for applications that require live updates, such as live sports scores, stock market tickets, chat application, and real-time notification. This reduces latency and improves the user experience by providing immediate feedback. The most common protocol for streaming APIs is server-sent events or SSE, but others like WebSockets can also be used depending on the application's requirements. For example, these APIs are seen in ChatGPT, or if you have used OpenAPI APIs. A typical response is like this. You get a stream of responses. First, let's ensure that the processing a streaming response option in advanced setting is enabled to get started with the streaming responses. Typically, for streaming APIs, there are three response actions. On message, this action is triggered every time a new piece of data is received from the streaming API. You can use this action to update your UI or perform any logic with the incoming data in real time. On error, this action is triggered when the streaming connection encounters an error. You can use this to handle errors gracefully, such as displaying an error message to the user or attempting to reconnect. On close, this action is triggered when the streaming connection is closed. You can use it to perform cleanup tasks or notify the user that the stream has ended. In FlutterFlow, when you select a backend call within a stream API, you will see all the actions of that type. Then you can use the action flow editor to each to set any subsequent action that can happen. For example, for onMessage, you can read the data from the response and set it as a page variable or similar. Everything is fairly similar to what and how we have done for actions in the previous modules. Before we move on to the demo, let's talk about response stream message options. Just to understand a bit more about messaging, FlutterFlow provides several options that capture different parts of SSE. Let's start with message text type string. This includes the entire server sent event message, including new lines and fields. Here is an example on the screen. Server sent data JSON, or the type JSON. This field captures the result of a JSON parsing. For example, as you can see, the data is going to be a JSON on this example, as response is hello and version is 7. Note that if the data is not in JSON format, it will be null. So here is an example where the message type is JSON, but the data is not. Therefore, the server sent data JSON would be null. If you change the server sent data to text type string, this field contains just the text of data field from the SSE. If there are multiple data entries, they are concatenated with a new line. For example, from the event, as you can see on the screen, the server sent data text would be the server time, which as you can see in this screen. And from the event, here is an example. When you have multiple datas, the server sent event text would be a concatenation of each of those data in a new line. The server sent event name, if the type is a string, this field contains the text of the event field from the SSE. Here is an example. The event text in the field is going to be ping. And if server sent event ID or a type of integer is defined, this field contains the text of the ID field from the SSE, typically used to keep track of the last item sent from the server. Here's an example. You get this, and the server sent ID would be 2. And then finally, the server sent event retry, type string or nullable string. This field contains the retry field from the SSE, typically used to communicate to client when try to reconnecting to server. All right, this is all about the concepts right now. Let's go to the next video and actually see it in action, and I guarantee it all will make sense. All right, back to my project. So I created a new page right now called chat page, and I want to try to create a ChatGPT style in my application. So this chat page is using very simple components. So as you can see, it's a text field, message field, and then a button, and also chat bubble component. And if I open the chat bubble component, you will see that, let me open the widget tree. You will see that it's just a column with two columns, which each column based on some criteria is going to be shown. Like, is AI is going to be this one. And if it's not, then it's going to be this one. All right. So, and this component already have, let me just open that, two parameters. The first parameter is going to get the list of a string, which these strings is going to be wrapped with a wrap widget. So we now have a wrap widget. Here is the wrap widget. And this wrap widget is going to wrap all of the text here. And that's pretty much it. And there's one more thing here also. Each of these texts, when they are appearing on their load, there is an animation as well, which the animation is the fade, and there is a duration of 500. And this is just applied for the AI one. For the human text, there is no animation. And that's pretty much it for our chat. But now there's no data in this page. We need to go ahead and just do this. We need to go ahead and try to create this with real data. For this chat, I'm going to use OpenAI API just to try to create the chat compilation similar to ChatGPT. And when you look at the documentation, here is a post method for this endpoint. And there is two request body that we need to pass, and that's a list of messages, which is required, and a model. There's also an example here that how we can send it. It's a JSON that we need to send plus two headers that we need to set. And for the authorization header, we need to create an OpenAI API key. To do that, you can just go to dashboard and then go to the API key and create a new key. And once you create it, copy that key. So there is one more thing here. If I scroll down a bit, you will see that there is also a stream property here, which it can by default is false. But if I want to make something like ChatGPT, I need to make that true. And if it becomes like a stream, then this is how you get the response. So they are coming as chunk. And this is what we're going to work with it right now. All right, let me just copy this and go and create it in FlutterFlow. All right, I just created an API call and named it ChatGPT. This is a post method, and that's our endpoint. And I pasted my authorization header here with the token that I created and the content type of JSON. I also pasted the body that I just copied from there. And as you can see, at least we're going to have one message, and that's going to be the role of user, which is us. We're going to send that. And the content, and this content is a variable right now as a type of a string. This variable is going to be the prompt that we are going to write. And I already enabled the stream here as well. So there is one more thing I have done here is that in advanced setting, I made this call private because this key is sensitive and secret. We should not really add that to our mobile application. So, and therefore also I enabled the required authentication. Only logged in user with Firebase authentication can make this call. Plus, I also enabled process a streaming response. All right, sounds good. We need to go ahead and deploy our APIs because we made this private. That will deploy cloud functions for your project. So now we can go ahead and test. So let's go to the respond, and I'm going to add a prompt here. Hello, can you help me? And let's test it out. There you go. And if I now scroll down, you will see that we are receiving chunks of data here. And in fact, if you look at the first chunk, you will see that the delta here under the choices, which is only one choice, has role of assistant, and a content will start from here. And the next one here is the second chunk. It only has the content. And of course, if you come down, you see the rest of the content as a chunk is coming. All right, so we need to parse this right now. So let me go ahead and copy this JSON, the first one, which is the complete one. And I'll go to data type and create it from JSON. Let's call it chunk response. Beautiful. So now I have my chunk response, and as you see, I have the choices, which is a list of choices. And if I open the choices, this is gonna be a list of delta, which the content was there. And if I now open the delta, the content, role, and refusal also are there. Beautiful. This is exactly what we were looking for. So now I can go back to my API call. And this time I can parse each chunk as data type of chunk response. So pay attention that this is not a list. Please do not check this because you're receiving chunks as a stream of data, not a list of data. All right, beautiful. So let's go ahead and save this. So we're ready right now to go and implement it in our page. So what we want to do right now, when user is going to enter on this button, so let's go and add an action here. And on tab, we really want to make a call to OpenAI. And this call is going to be the ChatGPT call. But this call is different from other calls that so far we have seen. We now have a streaming response action, which is on message, on error, and on close. What we need to do, we need to handle the on message when the data is coming so we can actually update our state with the new messages and show it to the user. And if I open this, you see that I can create more actions. Okay, what should we do here? To handle these data, I'm going to create two local page state. The first one to recognize if the message is the first message, and that should be the Boolean type. And by default, I will say this is gonna be new message. And the second state variable that I want is going to be list of messages. And what is that then? We need to create our own custom data for this. Let's go ahead and do that. So I'm going to create a new custom data called message. And what do we really want for this message? We want an ID just to recognize as a unique value for this message. Let's say this is going to be a string. And we also want the role, like who sent this message. Was it the user or the assistant or the AI? And of course, list of messages. So let's call it messages, which in this case is going to be a list of a string. Okay, that's the data we really need. And let's go back now to our page state. Let's quickly do that again. So we need the new message to recognize whether it's new or these are the subsequent response. That's going to be a Boolean. And by default, true. And also messages. I will name this state something else. Let's call it GPT messages. All right. So let's now go ahead and say this is going to be our data type and it's going to be a list of the message that we just created. Beautiful. Let's confirm. So what do we want to do here? Well, in fact, here's a list view on this page, and we're going to actually generate content dynamically for this list view based on the GPT messages. Okay, so let's go ahead and do that. So we're going to name this all messages, and that's going to be based on the page state of GPT messages. All right, confirm, save, and there we go. And now for each component, if I select the chat bubble, I'm going to pass that based on the all messages item, and we do have the data structure field, and that's going to be the ID of the message. And then I'm going to pass the text, which is going to be the list of messages. And I'm going to say here if this is an AI or not based on the role. So in fact, here I'm going to say if in my all messages, the role is, let's say, is not equal to user. All right, confirm. Beautiful. Now we need to complete the submit button. So when we open this action for the first time, so user is actually adding a new message. So we need at least one action here to update the page state. What do we want to do here? We're going to say the new message, when you open or click on this button, is actually going to be true. It's going to be a new message. All right, that's good. So we're going to move that up. And there's another thing we want to do here as well, is that right after this, we also want to add the user message to our state. All right, that's good. Let's just go and update page state. And in this case, we're going to actually get the GPT messages, and then we're going to add an item to the list. So let's select the value for that. That's going to be a message. And now we need to create our message here. So we need an ID, which in this case, I'm going to select the user ID. And then for role, I will manually write user. So whenever user types, the role is going to be user. Let me just collapse this. And the third one is going to be messages, a list of messages. And that's the prompt that user is writing. But the prompt that user is writing is one string. We cannot assign it to a list. But how can we fix that? That's very simple. We're going to use code expression. We use code expression and we define an argument, let's say as prompt. And here, then I pass the widget state, and that's going to be message field where user is typing. And what I'll do here, I'll just wrap this prompt with an array. Let's see if everything working. Of course, we need to also return a list of a string. Okay, let's try again. All right, no error, everything fine. Let's confirm and confirm. So what happens is that now we're going to say first, set the new message is a new message. Fantastic. Then add the user prompt to the list, which is nice. And then call OpenAI GPT. All right, that's very good. But then we don't really need here for the condition. But I'm just going to say in this case, let's just terminate this for now. And we're not going to use this for now. But what we will do, because this stream is a bit different, we need to go and handle the onMessage. And in onMessage, let's add a conditional action. We need to have two paths. If it's a new message, then you have role and you have ID, so you need to create a new message. But then after that, you will receive subsequent messages. So in this case, you need to update the first message that you received. So we need two paths. Then based on the page state that we defined as current or new message, we can decide if this is new message, then let's go and create an action and update our page state. So first thing we want to do here, immediately we're going to say that the new message anymore is not going to be new message. So from now on, it will be actually no new message. Okay, that's not a new message anymore. So then if for the first time you come here, you do something, the second time it comes there for the condition, it goes to the false path. Beautiful, that's good. So let's fix now the next action for the true path. And now we want to add the message to the list. So I'm going to go and get now GPT messages. And now say I'm going to add to the list. And we need to add a message to the list. And we do need ID, which in this case is going to be the action parameters on message input. And on message input, you're going to have several options. And as you can see, these are for server sent event that we have discussed in the previous video. But for now, we're going to go and use as data type. The structure that we define is chunk response. And here is the ID. Beautiful. Now we need a role. So I'm going to use the action parameters, data type, data structure is going to use the choices, item at index. Let's get the first one. And then you're going to have delta. And then here is the role structure. Beautiful. Let's do now the messages. All right. What we're going to do here, I'm going to go and say the value is from action parameters on message input as type, data structure, choices. And the choices though, now I'm going to map list item. So in this case, what I can do, then I can go and find the data structure for the choices and get the delta and just map the content in this case. Beautiful. Confirm. And now we have also a message. All right, confirm. We're going to get all the messages, like the content, for the first time into our GPT messages page state. So we're done here. Now we need to go through the false pass. What do we want to do there? First, we need to update our page state again. So here, I'm going to get the GPT message. But what do we really want to do here? So last message that went through the true path, now it's already in our list. And it's in the last item of the list, right? So we need the last index. We could also store the ID of the last message and then use it here. Both is possible. So now I'm going to go for the index. I say I want to update the item at the index. But what is this item at the index? Is the last item of the index. So we don't have such a functionality that I say last, but I can create a custom function for that. I'm going to go and create a custom function, and I will call it last item index. Okay. So then this is going to return an integer, which is just a number, and then we're going to pass our messages here, which is going to be a list of data type of messages. Great. So now let's go ahead and write the logic. So it's very simple. In fact, we're just going to go and check all the messages and see what's the length of that. So for example, if we have 2 items in the messages, then the last index is going to be -1. And that's it. As simple as that. So let's go ahead, format the code, save this function, and now we have another function here, which now I can pass my messages. So let me go and select my page state, GPT message, confirm, and now this function is giving me the last index of GPT message of page variable state. Okay, good. Now we have the last item. What do we want to update? We want to update fields. Which field do we want to update? Messages. And what do we want to do with message? We want to add to the list. And what do we want to add to the list? That's what is coming from the on message input. For the second time and onwards, we can get the content only. So then you can go and select all the way to the delta, and there you can just select the field of data content. And we're done here. Let's close. All right, let's see what are the errors here. So we have two errors here. Let's just quickly fix. This needs to be built quickly. And the other one needs to make sure we are deploying our APIs since we make changes. Before we do a demo, let me show you one more thing. And here is this message field, right? So when you type and when everything is going fine, then you want to also clear this text field. So let's go back to our action. And this is what we're going to do right after this call. We're just going to say here, there is an action of clearing the text field and pin codes. And as you can see, we have now a text field appearing here. This is our message field. Let's just check. All right, so now that we have added this action too, let's also do one more change, and that's the backend call. So we handled the on message, and we also need to pass the variable to the call. And that variable is going to be our prompt. Let me just go ahead here and select the content. And that content is going to be the widget state and the message field text. All right, there we go. So now we are also passing the prompt to the call. That's it. Let's go and test it out right now. All right, the app is loading. Let me go to the chat. Let's start with a simple question. Hello there. Okay, and let's ask another question. What is FlutterFlow, for example? Beautiful. Let's ask another question. Can you write longer, up to maybe 500 words? Let's see. So nice. All right, so this is working as expected, and we have now created a ChatGPT-like chat with OpenAI API. It's time to check the generated code of what we have done. So if I now open my library folder, you will see that under the backend, I will have the API request folder. This is new that we have worked so far in this module. So this is an interesting one as well, because you do have the streaming API as well as and all of the interceptors that you also have created, plus the APIs that you created. Okay, so let's go and check API calls in this case. These are the API calls that we created. We created a ChatGPT call, and this was making a cloud call HTTP because we made these API private. So in fact, this function is going to make sure that your private APIs are going to be called through this cloud function. Okay, so that's beautiful. And then let's go back. Then we had other APIs here. So for example, we did have get category call, and the grouping that we also created, it appears here. And as you can see on the grouping, we do have Interceptor, both Interceptor that we just added. And if I just open this Interceptor, you will see that it's just a class that is extending FFAPI Interceptor, which has on request, which we already added this parameter to it, and on respond. And for the other interceptor, the header, we just modified the header. Okay, beautiful. So now I'm going to go and check out the other group, which was the order group. And as you can see, when you define the group, it comes with some high-level configuration for all of them, including the get base URL. All right. So now let's go and see how APIs are called. The API is going to be called by making an API call on API Manager. As you can see, these are unified among all of the other APIs. Let's take a look at then API Manager. And that's the API Manager. Okay, let's take a look at the API Streaming. So you'll see that you have a class here as server sent event. We went through that in the concept video, but now you can also see that in the code where you have the event data, and the data are type of JSON that is going to be decoded. So, and here is also a thing that you have another type of class, response stream messages, where it handles the server sent event in this case. So, and all of the messages are coming here, getting parsed and back to you. And you see that messages are parsed in this line by line. We already went through how these messages are coming line by line. And now if you go back and check out the concept of streaming APIs in the last part, it very much makes sense if you look at this code. All right, these are all the API requests. And what else we've done that we should see? We had the chat page that we created in this case. All right, now let's open the chat page widget. So in that page, we had a button that we have defined our on tab action. So let's go through that quickly. You see that it's already coming here, the actions that we created. We started by setting that the new message, which was a page variable state, so then it's going to be true in this case. And then we moved on to adding the ChatGPT message to the list. And then after that, we called our ChatGPT API that we created. And you will see that now, upon success of that call, then we had a stream of response. And then in all of the response that we received, if the message was new, we've been doing or adding these messages to the list for the first time. And otherwise, if it was the second or subsequent messages for the first message, then we've been updating at the index. And this was the function that we just created, last item index. Let's take a look. So this is exactly what we've written in FlutterFlow. And you can also see you have on error as well as on done. So which was on error and on close in the actions in FlutterFlow. All right, beautiful. All right, I'm going to show you one more thing in the ChatGPT model. So we created two page state variable, which is going to be created under ChatGPT model, right? And that was the new message as well as the GPT messages, which because the GPT messages was a list, it already also had several helper functions here as well, which you have seen that in the actions when you've been working with the GPT messages. All right, beautiful.